A transistor is an electronic component capable of acting as a switch and also as an amplifier. Basically, a transistor consists on two diodes. If we add a type N semiconductor section to our original diode at the beginning, and we reduce the thickness of the semiconductor type P, we will have the basic structure of a transistor. Regardless of the polarization of the voltage source that is connected, the current will not be able to pass, so it will act as an open switch. If we want a current to pass through our transistor, we can add a small voltage difference in the semiconductor type P, it letting the current through because type P semiconductor extremely thin. This means that when are sending a signal with a small voltage and obtaining a result with a higher voltage, that is why it is said that a transistor can act as an amplifier, or also as a switch if it completely prevents the flow of current. The transistor we just saw is known as NPN bipolar junction transistor. The connector on the left is called a collector, and the one on the right, emitter. The type P semiconductor connector is known as base. It is able to control the current can be transmitted between the collector and the emitter. Another way to understand a transistor is to compare it with a stopcock, on which the pipe is the collector, the base is the key that controls the flow of water, and the emitter is the water outlet. In the first case, we will be in the cutting region where the base voltage will be lower than the other two connectors. Therefore, the reaction that will allow the passage of current between the collector and the emitter will not start, meaning that our valve will remain closed. In the second case, we will be in the active and direct region and gradually increase the base voltage, which will increase the flow of current from the collector to the emitter in a direct proportion. The third case occurs when the base voltage is too high, and therefore the transistor begins to act as a simple cable, letting all the current from the collector to the emitter and losing the amplification quality of the active region. And finally, the fourth case is the inverse active region that acts in the same way as the direct active region, but transmitting the current in the other direction. This occurs because a transistor is symmetric and therefore can be used in both directions. Thanks for watching. Like, comment, share, and follow.